We took a look at labeling prisms in the previous video and how to name prisms. In this next section, we're going to talk about how to calculate three main things: lateral area, total area, and then volume of prisms. We are, in this course, mainly focused on right prisms. A right prism is a prism in which the lateral faces are rectangles. So as you see in the three diagrams from the previous page, each one of these have lateral faces that, as I'm shading it in, happen to be rectangles. And as such, what you notice is that one of the lateral edges, the edge that connects two lateral faces, is perpendicular to the edge of, or the base itself. So it forms a right angle with the base itself. And so therefore we can conclude that that lateral edge was actually the altitude. With an oblique prism, what you notice is that the lateral face, instead of being, so this is the side closest to us, is instead a parallelogram. And so that's defined right here. We don't really focus on this in these types of scenarios. We have to calculate what the altitude is by dropping from the top vertex of the base a perpendicular segment to the horizontal that is formed with the edge of one of the bases down below. And so that's beyond this course. This is more of an advanced topic. So when we discuss the three main calculations below, it will be pertaining to right prisms. So I'm going to highlight for you guys so it's nice and clear, and I'd like you guys to do the same thing. The definition of lateral area, the definition of total area, and there should be one down below here on the volume. And there is a classification of a cube that we'll talk about as well. Oh, so here is the volume, which is not in bold, so even more important that we highlight that. And so the lateral area is what you would picture when you're describing the lateral faces, the area of all the lateral faces. So essentially it's the sum of the areas. So let's go ahead and fill in the blank here. Sum of the areas of a prism's lateral face. And let's make that plural because it's all the lateral faces together. So we're going to sum that all together. So if we take a look at an example of what that means, it would essentially mean, as I highlight this, you can see that on the, let's go ahead and focus on the far left figure, that we're going to take this rectangle here, add it to this rectangle here, the area, add it to the back rectangle, and then to the left rectangle. So in other words, we would need the base and then the height of each one of the rectangles. So notice that the height is the same for all the rectangles as we go around. So the formula for it can be summarized as taking the perimeter of the base and then multiplying it by the height. Essentially, we are multiplying the height to each one of those sides, and that's going to allow us to come up with the sum of the area of the lateral faces. I want you guys to visualize this as best as possible. So even if you don't remember it as perimeter times height, if you remember lateral area as simply the sum of the area of the sides of your prism, you can just go through and calculate, okay, the area of this rectangle plus the area of this rectangle plus the area of this rectangle and then plus the area of this rectangle should give me the total lateral area, or let's just say lateral area. So down below here, the formula that you'll see that we'll eventually summarize is, and I will highlight it in a different color so it's more apparent for you, but lateral area is perimeter times height. Now, if we went ahead and talked about wrapping a present that was in the shape of a box, that's a rectangular prism, we would need enough wrapping paper not only to cover the lateral faces, but also to cover the top and the bottom. And so that's what we call total area. So total area includes the area of the bases as well. So when we look at the next formula, total area is lateral area plus 2b. I'd like you guys to go ahead and circle the b And make note of that B standing for, so B is area of base, because you have not only the area of the base on top, but the area of the base on the bottom as well. So lateral area plus 2 times the area of the base. A cube is a special form of a rectangular prism in the sense that the height is the same as the dimensions of the base. So the base being a square, and then we see that this edge right here also happens to be equivalent to each one of the sides here. So we're thinking of like a Rubik's Cube, a perfect shaped rectangular prism with all sides being congruent. Lateral edges with the bases of the side length of each one of the bases. So the lateral area of a cube, let's go ahead and calculate that. So if we first think of just the lateral sides, we have side squared here, plus another side squared back there, plus another side squared here, and then the left side squared. So a total of 4 sides squared. So lateral area for a cube, and rather than memorizing formulas, I want you guys to visualize it, think of it conceptually. So we have the 4 sides of the cube, and then total area would include the top as well as the bottom, and those also happen to have the same area s squared. So if we add another s squared and another s squared, we get total area is 6s squared. And then finally, the volume of a cube, well, if this is s, and this is s, three-dimensionally, it would be the area of the base, which is side squared, times the height, which is another s. So in other words, side squared times s. So volume most of the times with a cube is summarized as just side cubed. Now, when we talk about the volume of a prism, a regular prism, I'm going to draw, and I skipped over that discussion, so I'm going to go back to it. Let's go ahead and draw a rectangular prism here. And we see this more when we get to AP Calc, but if you think of volume as the accumulation of area that you stack, let's say the base on the bottom, and you stack an infinite number of squares on top of each other, and you sum up all of those squares, you get what we call volume. So with our formula, the idea is you start with the single base on the bottom, and there's h number of them that we're stacking high. So you're multiplying this unit of measure, the length and the width of your base, and then timesing it by the height. Now that works if it's a rectangular prism, but what happens if we have a pentagonal prism or a hexagonal prism? So what we have to do is just adjust the area of the base. So the formula for the volume of any rectangular prism, which I'm going to have you guys highlight in pink here, is base times height. And again, the B stands for the area of the base. That's probably the most confusing part for students when they go back and look at the formula. That represents the area of the base and then the height itself. So once again, the height would be determined as this length right here, the altitude. So I'll mark that off as h here. Now let's do 3 examples. In each one of these examples, we're given a figure. The last one, example 2, we don't have a figure, so we can draw one. But the first one we would classify, because there's going to be a part of your homework assignment where you guys are classifying what the name of that prism is. So in this case, this prism is summarized by the fact that the base is a triangle. So this is a triangular prism. They want us to find 3 main calculations: lateral area, which on the homework assignment I might refer to lateral area as LA, total area as TA, and volume as V. So let's go through and calculate each one of these things. So let's start with our lateral area. Assuming this is an isosceles right triangle, I think one of the measurements got cut off, this being 5 centimeters here. Let me write that a little bit more clearly. So this leg is 5 centimeters. Now, if we were to calculate, and since I have some space over this side, I'm going to use that so that I have some space for question B over on the right. The lateral area is the sum of the areas of the rectangles that you see. And the formula that we saw above was we needed to calculate the perimeter and then times it by the height. So in this case, if I calculate the perimeter, it would be 5 plus 5 plus 6. So let's first write the formula out. The formula is perimeter times height. It's the perimeter of the base, which would get us 16. And then times the height, because that's going to give you the other dimension of the rectangle. So essentially, we're adding this rectangle, the rectangle on the right, and then the rectangle on the far back. And so it's 16 times 7. So if you calculate that, you should get 112. Since this is a measurement of area, it's square units, so 112 centimeters squared. Now the next calculation is asking us to find total area. I'm going to switch colors just so that we have a clear idea that we're into a different calculation. So total area would include the lateral area plus 2 times the base. So in this case, the lateral area that we calculated from above is 112. So I'm going to carry down 112, and then I'm going to add 2 times the area of the base. Now let's go ahead and do the area of the base calculation here. So B is equal to, let's look at what B is. B is a triangle. So if I were to look at this triangle, focus in on this triangle that I'm going to highlight here, I notice that it's an isosceles triangle in which the base is 6, but we are missing the altitude. So let's go ahead and drop the altitude down and see what happens. When we drop the altitude down, that's going to form a 90-degree angle. It's also going to split our base so that each one of these segments are 3 units long. When we do that, we see that we can now apply Pythagorean theorem to figure out what the altitude is. So we've got a 3, 4, 5 right triangle, or in other words, use Pythagorean theorem to calculate that this is 3 squared plus x squared equals 5 squared. We should by now know that 3, 4, 5 is what we call a Pythagorean triple. And so our height is equal to 4. So calculating the area of the base, we've got 1/2 the base of the triangle is 6 units long. The height is 4 units long. So we're going to substitute 6 in and 4 in. I'm going to transfer that over to the left-hand side where I already had 2 there to represent both the area of the top and the area of the bottom. So again, the 2 is to represent, we have both a top that we're going to add to our total area and a bottom. So 2 times 1/2 times 6 times 4. The 1/2 and the 2 will cancel. So then we're left with 24 in our calculation. So 112 plus 24 is 136. And again, this is a calculation of area, so we're going to make sure we include centimeters squared there. And our last calculation is that of volume. So I'm going to switch colors to green here. And our volume calculation required the area of the base, one base, times the height. So in this case, the area of the base I have as 1/2 times 6 times 4. And then the height of this entire prism is represented by this lateral edge, which is 7 centimeters long. So we also have to multiply by 7. So 1/2 of 24, the calculation we've already done, 1/2 of 24 is 12. So we've got 12 times 7 is the volume, which is 84. We're going to represent our unit of measures as cubic units of measures, so centimeters cubed. We're going to do something similar. This time we have a trapezoidal prism for part B. So for part B, let's start with lateral area. So lateral area is calculated as, and I'm going to erase this 5 so I have a little bit more space here. So lateral area is equal to the perimeter of the base times the height of the overall prism. So when I calculate the perimeter, I'm adding 9 plus 16 plus 8 plus 22. As part of your notes, you can include that. So you can write out 9 plus 16 plus 8 plus 22, and then multiply the height of the entire prism, which happens to be 10. If I multiply everything out, the first thing I would suggest you guys do in a calculation like this is calculate this on your calculator. You should get 55 for that. Times it by 10, and we've got 550. Unit of measure is not provided here. So if it was inches, so let me go ahead and add one of the units of measures here. Let's say it was inches, this would be inches squared. So keeping with that same unit of measure, let's go ahead and calculate total area. And let's switch colors to blue so it matches the one that we just did. So the total area calculation for this would be whatever your lateral area is, because we've already calculated the area of all the rectangles that you see, and now we just have to add 2 times the area of the base to account for the top trapezoid and then the bottom trapezoid. So in our calculation from above, our lateral area was 550. We're going to attach the 2 that is part of our formula to account for 2 times the area of each one of the bases. And then now we're going to insert the formula for the area of the base. In this case, the area of the base is going to be that of the trapezoid. So if you remember back to the trapezoid, it was height divided by 2. So our height for this trapezoid is 5 divided by 2 times base 1 plus base 2. So 22 plus 16. Now in doing our calculations, we've got, this is 550, and the 2 times the 5 halves, the 2 cancels out, and you've got plus 5 times 38. In multiplying 5 times 38 out, you guys should get 190. So 550 plus 190. And that's a total of 740. Again, units will match what it was for lateral area, so inches squared. And then finally, our calculation for volume in this problem is going to lead us back to what our calculation was for the base, and then times it by the height. So since our base was the trapezoid, I'm going to look and focus in on the area of the trapezoid, which is here. Highlighted it. It's equal to 5 over 2 times 38, 22 plus 16. And then we want to multiply that by the height of the overall overall prism, which is 10. So 2 goes into, you can divide 2 into 38 and then times it by 10. We should get a final calculation of 950, and that would be inches cubed because we're in cubic units for volume. Now our very last question, example number 2, doesn't give you guys a picture, so let's go ahead and sketch that. You've got a right triangular prism. So let's draw a right triangle means that one of your bases is a right triangle. Has a base edge of 5, 12, and 13. So we know that the longest side has to be 13, so that means the other 2 sides have to be 5 and 12. So this means that you've got 2 congruent bases that connect to make kind of a cheese wedge looking figure here. And we know that that's a right angle, so we know therefore that this is the base and the height of the triangle. And it's telling us that the volume is 450. So let's write out the formula for volume. So volume is base times height. Find the height of the prism. Just said prison. I meant prism. Find the height of the prism. So in this case, we're going to substitute 450 in for volume. The base calculation is, since it's a triangle, we're going to do half times the base, which is 5, and the height, which is 12. Of the triangle, we're focused in on the area of this triangle. Base is 5 here, and then height is 12. And then we're trying to figure out what h is. So 450 equals half of 12 is 6. 6 times 5 is 30. So 30h. Divide both sides by 30 to isolate your height, and we get h is equal to 15. And this is no units of measure. So again, if there was a unit of measure, it would be a singular unit of measure, and that would be your answer. So I'll just say 15 units.